Okay, so in this sort of setup video for the last portion of divisibility, we're going to focus on polynomial rings, in particular polynomial rings over a field. And so I just want to remind you how to carry out long division when we're dividing polynomials. Um, in polynomial division, it matters what the field is. So here we're specifying that the field that we're going to carry out the division in is Q, and then afterwards we'll do an example with a finite field. So let's divide x squared plus x into x to the fourth minus 1, and so there's an x to the fourth, there's no x cubes, there's no x squareds, there's no x's, and then there's a negative 1. All right, so what do? We take the leading term and then we divide it into the leading term of the what's under the radical. X to the fourth divided by x squared is an x squared. And then we're going to multiply the x squared into x squared plus x, and we get x to the fourth plus x cubed. And then we subtract that. All right, when we subtract that, the x to the fourths go away, and what we're left with is negative x cubed. Great. And we're going to divide the x to the squared into the negative x cubed. Scroll down a touch. That'll give us a negative x. And then we multiply the negative x in. That's going to give us a negative x cubed minus x squared. And then we subtract that. So it'll make all these signs positive. We'll get no x cubes and then a positive x squared. Then we divide the x squared into the x squared. We have a 1. Multiply the 1 through. X squared plus x. Subtract that. We have negative x. We can't divide anymore. Bring down what's left. So what have we learned here? We've learned then that x to the fourth minus 1, when we divide that by x squared plus x, the quotient is x squared, what did I write? Minus x plus 1. And then the remainder is negative x minus 1. So here's our quotient. And then here's our remainder. Okay, so that's a quick reminder on how that would work, in this case in the rational numbers. We didn't actually need to invoke any division here, any fractions. It just sort of worked out, but you will encounter fractions. And then let's carry out another division. Let's work over, let's divide, let's see, x to the fifth plus x to the fourth plus 1 by x cubed plus x, and this time in F2, which is again just Z2. We're just emphasizing that it's a field. Okay, so what do? We do the same thing, x cubed plus x, divided by, we have x to the fifth, we have an x to the fourth, we don't have any x cubes, we don't have any x squareds, we don't have any x's, and then we have a 1. Great. Now, let me remind you here that in Z2, 1 and negative 1 are the same thing, and anytime we encounter a 2, we get 0. All right, so let's do this. So x cubed divided into x to the fifth is x squared. Then we multiply the x squared into the left-hand side here. We have x to the fifth plus x cubed when we do that. And then we subtract it, but subtraction and addition are the same in F2 because 1 and negative 1 are the same. So we're just adding these. We're going to get a 2x to the fifth, but 2 is 0. So we're going to get an x to the fourth plus x cubed when we do that. And really there's that 1 hanging out on the side, but we'll get x to the fourth plus x cubed. And now we divide x cubed into x to the fourth. So it goes in with there's x left when we do that division. And then x times x cubed plus x is x to the fourth plus x squared. And again, I should subtract it, but in F2, subtraction and addition are the same. So we just add them. So the x to the fourths will go away because 2 is 0. And we get x cubed plus x squared. And then x cubed goes into x cubed exactly once. And then we multiply that 1 through. And then we add, 2 is 0, so we get x squared plus x. And then now our our power is less than 3, so we bring whatever's left down. So what we've learned here is that in this field, x to the 5th plus x to the 4th plus 1 is x cubed plus x with quotient x squared plus x plus 1 and remainder also x squared plus x plus 1. That was an accident. Nevertheless, this is our quotient and this is our remainder. Right, so just a quick reminder on polynomial long division. And polynomial long division works in any field. In particular, you'll do lots of problems in your homework on finite field stuff.